Welcome to this webinar about RevoCaP, a revolutionary calcium phosphate product fitted for organic farming from recycled origin with a slow release focus. And this is very important. You will see this in this coming webinar from our distinguished speakers. We will have first from FiBL, the Research Institute of Organic Agriculture, Symanczik, that will present about the background, why it's so important to recirculate phosphorus. We will also have Jenny from Grobruket explaining about the potential for recirculated phosphorus when it comes to the market dimension. And they've done a study over Europe to understand where are the biggest potential. And then, of course, we will explain more about the product as such. Therese Åström from EasyMining and our research center will describe more about the details. But of course, Philipp Theuring, this is the person that you should contact going forward. Our key person in Germany that are now working responsible for putting the product on the market. My name is Larshans. I'm Chief Sustainability Officer for Ragn-Sells Group, the owner of EasyMining. And we have been around since 1881 or even earlier. And we are now a third generation family owned business. And for us, phosphorus and agriculture has been a key component of the DNA of the family since we started. So for us, this is very special and also special to can offer a product to a market that is so important for the future. Why is phosphorus so important? Well, what we see is that phosphorus are a key ingredient to produce food in the world, and very scarce where you can source it from, meaning that there are a few places in the world where you can mine the phosphorus. There's a lot of other problems when I talk about mine phosphorus, and especially that it pollutes the society where it's produced, but also that you produce a product that are often with high solubility, even in water, and that creates risk for eutrophication. We will cover that also in this session. In September, I was invited to the UNFCCC Climate Week conference as a keynote speaker to present how circularity can transform the society and also make sure that we fulfill the ambition set in the Paris Agreement. And our phosphorus product or our phosphorus process was one of those topics, meaning that we can produce an end product that has a high value, that we reduce the cost for the cities in the end to treat their sewage sludge, and by that enabling that we can catch more of our phosphorus in the sewage. So it's a very, very effective step to make sure that we recover more phosphorus in the future, because the more phosphorus we have in the sewage sludge that we then incinerate and extract the phosphorus from, the higher will the value become, and the higher will the income be from the cities. Phosphorus are a key ingredient, but how important is then to recover phosphorus and use it in organic farming? I asked then Dr. Symanczik from FiBL, the Research Institute of Organic Agriculture in Switzerland, and I would like to give her the floor to explain how important it is to be able to use recycled phosphorus, especially for organic farming. Over to you, Sarah.
So hello everybody, I'm Sarah Symanczik from FiBL, the Research Institute of Organic Agriculture in Switzerland. I'm working in the group Nutrient Management and Symbiosis in the Department of Soil Science. Today I will speak about phosphorus in agriculture, but before I'm starting, I will make a short presentation or introduction into FiBL. What is FiBL? So FiBL is a private foundation founded a bit more than 50 years ago. We are working across different agricultural disciplines, as you can see in the list here on the right. So beside the Department of Soil, Crop and Livestock Sciences, we also have the Department of Food System Sciences, the International Cooperation, and the Department of Extension, Training and Communication. These departments are located in Frick, so where we are located, but we have in addition a department in the French part of Switzerland, which is the Department of the Romandy. FiBL was the first research institute of organic farming, but during the last 24 years, the other FiBLs were founded. So FiBL Germany, Austria, there is ÖMKI in Hungary, and FiBL France, and the very latest founded one was FiBL Europe. So, but now I want to give a bit more general introduction about phosphorus in agriculture. So why is phosphorus so important in agriculture? Because it's a vital structure of the DNA. But in addition, it also plays an important role in energy transfer and storage, as well as in flower formation and seed reproduction. This is why it is a very important yield determinant. When we look at phosphorus in soils across Europe, a recent study found that there is unbalanced phosphorus stocks with higher stocks in the northern part of Europe and a bit lower stocks in the southern part of Europe. This highlights the need for a farm-scale phosphorus management, which is very important to balance this and very specifically apply phosphorus in agriculture. In contrast to conventional agriculture, where we face a P saturation in some areas, as seen in this figure, we generally observe a depletion of P under organic farming. Reasons for this soil depletion might result from the limited availability of phosphorus fertilizer allowed in organic farming, since many off-farm inputs of P are often restricted. This has slightly been changed in the past years. So when we are now looking at the phosphorus sources typically used in organic farming, most farms rely on the farm manure and compost as phosphorus inputs. Depending on the size of the farm, the application of farm manure and compost might pose a logistical problem, or the availability might be restricted. Besides manure and compost, there is a positive list of allowed commercial phosphorus fertilizers for organic farming. So we have dedicated lists for Swiss organic farming, but also other lists for France and the Netherlands and others. So these positive lists are established by FiBL and exist in several countries, as mentioned. And it helps the organic growers to select products that are accepted in organic farming. So there is different categories where phosphorus fertilizers are can be found. One of them is the category of the P-rich, so the phosphorus-rich fertilizers. There's just a small picture of that list. These fertilizers in this category, these are mainly based on rock phosphates. When we look, there is another category. It's the category of the multi-nutrient fertilizers. This category has grown in the last years with many new recycling fertilizers being registered. These products originate from different waste materials, including, for example, animal byproducts, plant residues, but also food processing wastes. And lastly, there is also the category which is growing, the category of biogas digestates and composts from commercial biogas composting or composting plants. However, like nutrient recycling, in this case here, it is shown for the phosphorus recycling. It is a navigation between constraints. The example I'm presenting here is an example from a previous project which was conducted during 2013 to 16, where the idea was to rank the fertilizers according to their performance in different categories. And these categories, as you can see, they had included phosphorus recovery, efficiency of the technology, but also the fertilizer value, so the phosphorus availability and the fertilization efficiency of the products, the organic matter content, the occurrence of pollutants and potentially toxic elements, as well as environmental factor, yielding an overall score, which should guide the farmer, for example, to select for a specific fertilizer. So since the past year, so this project ended in 2016. So since then, a lot was going on in the nutrient recycling sector, and many new technologies have evolved. So the need to make an update of such a list and to evaluate these fertilizers is urgently needed. And why is it needed? This is because we really need recycled phosphorus for several reasons. One of the reason is, of course, the phosphorus is a finite resource, so it is mined in a very few locations. The process causes environmental damage and the concentration of the reserves at few places, and it can cause also geopolitical issues. Furthermore, the use of easily available triple superphosphate, commonly uses also, which is commonly used in conventional farming, has also causes an phosphorus pollution, as it is easily washed into water bodies, causing eutrophication, and finally it can collapse water bodies. So with the use of recycled fertilizers, such the mining could be prevented, and also the pollution of phosphorus of the water bodies can be reduced. So we have a new project. The project called Scale It. It's the upscaling of efficient alternative for contentious inputs in organic farming. So in this project, we are looking for alternatives for contentious inputs. On the one hand, for alternatives for plant nutrition. So we want to reduce the dependency on conventional fertilizers and upscaling access to alternative nutrient inputs. So beside that, it's not only on plant nutrition, the project also deals with alternatives for plant health, animal health, and animal nutrition. But we are focusing in my department on the plant nutrition and alternatives. And I just want to give here a short outlook about the objectives. So the project just started in May, and one of our objectives is to assess the availability and the potential for upscaling nutrient recycling approaches and potential off-farm nutrient sources for organic farming. So really to get an overall picture what is out there, and also then to make, in the second step, to develop a clear and implementable multi-criteria decision support system. So something a bit like we have seen in the example of the pea recycling, so that we have a tool where we can see what are the pros and cons for some of the products, because as we said, for all the nutrient recycling technologies, it is a navigation between constraints, because some of the products perform better in one of the categories while they perform worse in another category. So there is probably not a one which is overall with a super good performance, but yeah, maybe this we will see. It's an ongoing process. We just started, and yeah, this is something we are working now in the future on. So, and with this, I already want to say thank you for your attention, and I'm very happy for receiving your questions.
Very interesting to listen to Sarah, especially when she states the need to replace mined phosphorus due to the high solubility in water, risking eutrophication to take place. And that's not a problem only for the environment directly at the place. It's also a big problem for the climate dimension. We see the rapidly increase of risk of increased CO2 equivalent emissions, in this case methane, because of these eutrophication activities. I also take with me the high demand for new or more phosphorus products, and also that we have no study planned when it comes to products that are possible to use in organic farming. So thank you so much, Sarah. Now I would like to welcome Dr. Philipp Theuring. He's the Marketing Development Manager for RevoCaP. Please give us the background who you are, your doctor's degree, for example.
Yes, thank you, Per, for having me here. It's great to join this webinar. My name is Philipp Theuring. I work at EasyMining as a market developer for putting all our products that we will soon produce now in the right markets to use them the most useful. I'm an ecologist, so I've been working in water resource management and environmental related fields for a long time, until I actually wanted to do more than research, but contribute to real change. And this is why I really joined EasyMining, because I think with what we do here to pursue a circular economy, we can do what we have to do to lead to a more sustainable future for all of us and for the environment.
Now we start to build the first phosphorus factory in Germany, an ash-to-phos factory. Please give us a description of what we will produce there, Philipp.
Yes, like I said, now we start to go from planning to reality. So currently we are building our first ash-to-phos plant in Germany, close to Leipzig, central Germany. It's growing as we speak, so it's under construction. And yes, what do we do there? Simplified, we use sewage sludge ash, that means incinerated sewage sludge from wastewater treatment plants. We use this ash and we put it in hydrochloric acid. So we dissolve all the constituents besides the silicates as a sand and then separate them and detoxify this ash as well. So what we do is from this ash, which is contaminated with heavy metals, but also has good constituents like iron, aluminum, and phosphorus, we separate them and make products. So, for example, in such a sewage sludge ash, you have about 9 to 10% phosphorus. So that's what we want to recycle and bring back to agriculture. So, but to do that, we have to get it out of the mix. And that's what we do. I will not describe the chemical process in detail now, but we end up separating that and in the end precipitate it with clean lime to produce a very clean calcium phosphate, which is our RevoCaP. And one point that is also very important, I just mentioned, we talk about 10% constituent of the sewage sludge ash. What do we do with the rest of it? And this is where it's very important to think really fully circular. You know, it's not only about getting the goodies out of it. You also have to have a concept what you do with the rest 90%, and that's what we do. So what we also recover is iron, and from this iron we produce iron chloride as a coagulant that will be reutilized in wastewater treatment plants again. So it's not only about closing the phosphorus loop, it's closing separate loops. We also recover aluminium from the ash, which we produce sodium aluminate out of, which is also a coagulant or actually another base chemical. And even the sand, which is the largest fraction of the ash, we recover that as well, clean it, wash it, so it's usable in the construction industry, for example, as cement replacement or in clinker production. So what we really end up is with not only one product, but with 4 different products. I mean, the sand is technically waste, but it becomes a product once used right. And the reduction of the waste of 95%. So that's pretty cool in my opinion. So we only have, of course, the heavy metals that need to get out of the ash. That is the only waste that we still have for now, because circular technologies are growing. So we may be able to use that as well in the future.
So the burning question is now, when can we expect that the RevoCaP product and the other products will be available on the market?
Yes, the first ash-to-phos plant is growing as we speak and should be going into commission end of 26, beginning of 27. That means by middle 2027, we are going to have the first products, which is going to be about a capacity of about 12,000 tons of calcium phosphate of our RevoCaP per year in the first year. After total ramp up by 2028, we're going to have 15,000 tons of calcium phosphate. And that's only from the plant in Skopa, because we are, of course, rolling out this operation. So until 2030, 2032, the amount will quadruple. So latest by 2032, we're going to produce 30,000 tons of calcium phosphate. And of course, a lot of tons of all the other constituents I just mentioned. So, yeah.
Good. Thank you so much, Philipp. I will definitely ask you to come back in the end to discuss the outcome of the whole seminar and a little bit more about what will happen next. So thank you so much.
Thank you.
We have now heard about the RevoCaP product or the revolutionary calcium phosphate product several times. I really now would like to have more detailed information about the product, and therefore I'd like to invite Therese Åström from the EasyMining Research Center in Uppsala to present more about the specific product.
I will present about our RevoCaP fertilizer, mainly towards the organic market, but of course it's possible to use it also in conventional farming. And this is me, Therese Åström, product manager nutrients, mainly towards the fertilizer application since 2021. I'm an agri-technician and also partner to a farmer of 1,000 hectares, meaning that we are handling around 700 tons of fertilizer per year at home. But this is today's star, our RevoCaP fertilizer, recycled calcium phosphate. And I think Philipp has already mentioned the process and the raw material behind it. So the main focus here is of course the phosphorus content that I know is of biggest interest for fertilizer distributors and producers. And we are higher than, for example, apatite, but lower than other conventional phosphorus fertilizers. RevoCaP comes in two forms: powdered form, mainly towards raw material for compound fertilizers, etc., or granulated for the direct use as a slow release fertilizer. It's also suitable as a feed phosphate, even if I will focus on the fertilizer part for this presentation. And we fulfill the EU fertilizer products regulation within CMC 13. It's the component material category. Not sure about that, but okay. CMC 13. And we are also approved for organic farming since before summer this year. Here is a table showing how we detoxify in the Åström process. So the table shows the comparison between the untreated ash and the recovered phosphorus, and also the reduction in percent. And we have a reduction between 96 and 100% of all heavy metals, so it's a very pure product. And this is also showing the solubility of RevoCaP, and it's not soluble in water, but it is 80% soluble in ammonium citrate, which means that we need this biological and chemical reaction with the crop roots in the soil to release the phosphorus, why it's suitable for slow release application. And it's fully soluble in citric acid, why it's also suitable as a feed phosphate. We have done several agronomic assessments, and this is one of them. A glasshouse trial with the ryegrass, where we used triple superphosphate as a control. And the results show that in soils with pH 5.5, the effectiveness was 80% of the TSP. And we can also compare it a bit to struvite, since RevoCaP, like struvite, is not as effective in alkaline soils. We have also done a theoretical study, and Jenny from Grobruket will present this more in details after me. But with the background of the last slide showing suitable pH, etc., we had an idea that we wanted to calculate how we could use RevoCaP not only as a fertilizer, but also as a source for improving phosphorus levels in soil. So we wanted to map where these suitable soils are located and how we will need to applicate RevoCaP for getting most out of it. And the study showed good results. But our next step for EasyMining is, of course, to prove this also in practice. So to summarize, our RevoCaP are a 100% recycled calcium phosphate. It shows excellent uptake in crops and livestock. We are approved for organic farming. We can sustain the nutrient balance in our soils with the help of the slow release application. We have lower CO2 emissions compared to mined phosphate. And with the high purity of the product, we fulfill all relevant legislation. And this is it for now, and I will present some more about RevoCaP after Jenny's presentation of the theoretical study.
Thank you, Therese. I will soon ask you to come back, so I go directly to Jenny Faxå from Grobruket. Therese mentioned that Grobruket has done a market study about the potential for the RevoCaP product, especially because it's a slow release and the special conditions. So my big question is, of course, now, where are the biggest return on investments for farmers to use this RevoCaP product? Over to you, Jenny.
Hi, everybody. Thank you for tuning in today. I'm excited to share with you the results on our recent study on RevoCaP, where we looked at the impact of RevoCaP on soil phosphorus levels, crop yield, and farmer revenue. My name is Jenny Faxå, and I work with product development and consulting at Grobruket in Åström, Sweden. I have a background in international business and horticultural engineering. At Grobruket, we work with product testing and development, and our primary areas are fertilizers, substrates, and biostimulants. We also collaborate closely with the Swedish University of Agricultural Sciences on a variety of research projects. The purpose of the study was to analyze RevoCaP's impact on soil phosphorus levels, where we looked primarily at PAL class. We also looked at the impact on crop yield and farmer revenue. We used a program called DSAT, which is a widely used tool for crop simulations that combines data on soil, crops, climates, and other factors like fertilizers to see the impact on crops. Sorghum was chosen as a representative cereal crop for low phosphorus soils, and tomatoes as a high-value crop with a high phosphorus demand. And we compared these across European soils and climate conditions. Together, these crops gave us two very different but relevant perspectives. We ran simulations in 5 European countries: Sweden, Germany, Italy, France, and the UK, each with a range of different soils, varying pH levels and organic matter content, soil textures. And then we also looked at different treatment levels. So we had 3 treatments, one with no fertilizer, one with RevoCaP only, and then RevoCaP combined with organic residues such as soybean. We tracked changes in soil phosphorus levels and the time needed to reach effect, yield, and finally the potential impact on farmer revenue. The results of the studies showed us which soils were preferred and which crops were also preferred for RevoCaP. We saw that the strongest performance and strongest results were seen in acidic, sandy soils, such as those in Sweden, where phosphorus becomes available more quickly. Sorghum had a strong response in low phosphorus soils, whereas tomatoes gave very large revenue gains, especially seen in Germany and Sweden. In calcareous or clay-rich soils with higher pH, fixation limited the effect of RevoCaP, meaning that more time or higher levels of input were required to achieve the desired effects. The study looked at different application rates and the days it took to change PAL class. In all scenarios, we started from a PAL class of 1 and moved to class 2, and then also looked at PAL class 1 changing to class 3. We saw that Sweden had the most efficient results, and the Swedish scenario had a low pH and a sandy soil. It required 150 kilograms per hectare to achieve class 2 in 83 days. When combined with organic residues such as soybean, this amount reduced drastically. We saw it required only 50 kilograms per hectare and achieved class 2 in 58 days. The fastest effect was seen in Germany, and the German scenario had an acidic neutral pH and a loamy sand soil. It took 58 days, but required substantially more fertilizer. On average, across all the soils, the average requirement was 184 kilograms per hectare and took 74 days to reach class 2, while reaching class 3 required substantially more, which was around 400 kilos and took 128 days. For tomatoes, we saw that the effect came at higher rates. The fastest effect was seen in the Italian example. In Italy, the scenario had high pH and a clay loam soil. It required 132 kilograms per hectare and reached class 2 in 46 days. When combined with organic residues, this amount reduced drastically and took around 51 to 61 days. The most efficient scenario when combined with organic residues was seen in Sweden. Without organic residues, it required 520 kilograms per hectare and reached class 2 in 78 days. When combined with organic crop residue, it required only 29 kilograms per hectare and reached class 2 in 89 days. On average, across all soils, moving from class 1 to 2 required about 170 kilograms per hectare and took 100 days to reach class 2. To move from class 1 to 3, it required around 1,000 kilograms per hectare and took 100 days. Using organic crop residues cut this requirement by over 50%. Organic crop residues increase efficiency by enhancing microbial activity, improving nutrient retention, and reducing potential losses. Microbial activity helps to break down and dissolve the product and does this more efficiently, thus making phosphorus more available to plants. For sorghum, yields nearly doubled with higher application rates of RevoCaP. We saw that in Sweden, we needed 150 kilogram per hectare to achieve a yield of over 2,000 kilogram per hectare. This gave a net return of 37 euros per hectare and a BCR of 1.5. BCR is the benefit cost ratio, and it means that for every euro spent, this is the amount getting back per hectare. In Germany, yields were achieved over 3,000 kilogram per hectare when using 650 kilogram per hectare of RevoCaP. The best return was seen when using 450 kilogram per hectare of RevoCaP, which gave a return of 100 euros per hectare and achieved also a BCR of 1.5. In Italy and France, there was a minimal yield response, so the effect was minimal, and therefore it's not included here on the slide. If you look to the right, you can see our graph showing which levels of yield you achieved without using fertilizer. This is the baseline level. And then moving up to 150 kilograms for Sweden, you saw the yield increase, both with fertilizer application as well as combining with organic residue. In Germany, the effect was much higher, using at a higher application rate as well. The blue line shows the net return given at these different levels. For tomatoes, the revenue gains were even more striking. We saw that in Sweden, yields increased of about 23%, and in Germany by as much as 118%, with net returns of over 5,000 euros per hectare. The benefit cost ratios reached over 13 at moderate application levels. While this seems very high, it reflects both the high market value of the crop as well as the strong crop response to low phosphorus soils. In Italy and France, the effect was much smaller and less residues were added, underlining again the importance of using organic matter in these soils. Similar to the last slide, we also have the graph here again, which goes from the baseline level, and then you see the yield increase with the application rate and the net return in the blue line. So you see the very high levels of net returns as well as yields in the German scenario. To sum up, we saw that RevoCaP performs best in acidic sandy loam soils with a pH less than 7. This is due to that the soils allow for faster phosphorus release and therefore require lower input levels. In clay and neutral soils, we saw a weaker response to RevoCaP and a higher input needed, or that it took more days to achieve the desired effect. This is due to phosphorus fixation occurring in the soils. For sorghum and cereals, we saw that they had a lot of potential and efficiency in sandy soils and allowed for a moderate profitability. Cereals can respond efficiently in low P sandy soils, while high-value crops such as tomatoes give strongest returns when conditions are favorable. Using RevoCaP together with organic crop residues can reduce fertilizer requirements by more than half, allowing for better efficiency and a more sustainable fertilizer use. Overall, when the right soil is matched with the right crop, RevoCaP has strong potential to improve soil fertility, increase yields, and deliver farmer profitability. Thank you so much for listening and enjoy the rest of the webinar.
Jenny, very interesting. Tomatoes, payback time 21 times, if I understand it correctly, for the farmers. So now, come back again, Therese, and give some more information about the RevoCaP product.
All right, thanks, and back to RevoCaP and the ongoing development for our product. So with the result from the theoretical study we have made, this market analysis over organic farming, we have chosen to focus firsthand on Germany and the Nordics, mainly since we will have the plants here, but also Austria and Estonia, since they are large players in the organic market. So we think these are still valuable markets to keep an extra eye on. And in the analysis, we have looked at where in the country most of the organic farmland is located and what crops is cultivated. And we had help from a student this summer making this market analysis, and it could look a bit like this, the outcome from the analysis. I've chosen Germany because that's, of course, the #1 focus area since the first plant in Schkopau. And I've actually put it in here in the picture where it will be located. So this map is showing, or the text is showing what crops is produced and where in the country most of the organic farmland is located. By the greener it is, the more organic farmland it is. And another important aspect from this analysis is, of course, what certifications is relevant to apply for and what associations should we be part of. And we know that Bioland, Naturland and Demeter is large players in Germany. So here is the more practical ongoing development that we are having. We have a granulation project with the aim to have the best possible granule for the slow release application with the right shape and the right hardness, etc. in mind. And we have tried out different technique suppliers, but we're still analyzing and evaluating those and the granules to see which we think is most suitable. And I can just mention that we won't implement the granulation in our first plants. This will be an external solution. We are also looking into RevoCaP with an additive to improve plant availability. We have a master student now from October working on this, and it's behind a lot of patents, so I cannot talk about it in details, but it is to improve plant availability, and we'll compare apatite and triple superphosphate as well on ryegrass to get the quick effects and hopefully 2 harvests, and also maize to get a bit more slow growing crop with bigger roots. We also have planned field trials. So far we will participate in Lantmännen's strategy trial. Lantmännen is the Swedish farmers cooperative in Sweden, where we will test RevoCaP in autumn wheat in 4 different locations. And we're also planning for a potato field trials, probably also in Sweden, but at least in the Nordics. But of course, with this webinar, we are looking for customers and partners over Europe. We are planning for some trials, but we would like to be further down in Europe and do more trials there to see that it works in practice as we think. And we're open for trying it out as a raw material to compound fertilizers, to mix it with soil for getting a good planting soil, or to add other kind of additives, could be biological, for example, or to use it pure as a slow release. The most important for us is to find a partner that believes in a recycled and pure phosphorus product in the organic market. Even though we are also open-minded for a market niched more to the climate perspective or for the regenerative farming that we know doesn't necessarily need to be organic. And this is my last slide, the rollout plan for RevoCaP. Only powder then, since we will have the granulation external. And we will have the full-scale operation up and running for Germany already in 2028 or 2027, I mean. And for the second plant, we will have the full-scale operation up and running in 2031, as it looks like right now. And this will mean 30,000 tons per year, so 15,000 tons per plant. And we do have more plants in the pipeline, mainly for Germany, but I haven't included them here. So thanks for listening. At the time when this webinar is going live, I am actually on parental leave, but my email address below will forward you to my replacement, and I am sure that the Q&A will give some more contact details as well.
Thank you, Sara. Thank you, Jenny. Thank you, Therese. I will soon ask you to come back to respond to questions from the viewers. But before that, Philipp, make sure what you have seen now from the session. What is your view and what will happen next?
Well, what will happen next, as we also heard from people, a lot of things have happened in the last 10 years in the field of phosphorus recovery, especially from sewage sludge and sewage sludge ash. So what will happen in Germany, Austria, Switzerland? We already have legislations in place which are gonna hit soon and make it mandatory to recover phosphorus from sewage sludge, which is a great thing to do. And of course, what will happen, more and more companies will start doing it. We are probably one of the first ones, but also more will follow. So that means there will be more recovered phosphorus on the market. And of course, now it will be very important to see where can it be used in the best way. And if you have clean phosphorus recovered, you can utilize it not only for simple classic agricultural purposes, but yes, it can be used for organic farming. Yes, it has the quality level to potentially be used in even feed phosphates if you do it right. So that's what's going to happen. But of course, now what we need to do is we need to approach the farmers, the customers, the fertilizer companies, and share this. Also, institutes like FiBL, yes, they need to evaluate and give their recommendations also for improvements or whatever is needed. So, but we are at the brink of coming from theory and ideas to actually application, to make a real change, to make our German and European phosphorus market much more sustainable. So it's exciting times ahead.
What I take from the seminar is also that it also is very well fitted for regenerative farming, and that is really something that is trending globally. And it's very hard to put in phosphorus in that system by natural means. So therefore, this product that are so clean, that are so free from heavy metals, I think will be very suitable for regenerative farming with the slow release effect that is very important. If anyone has questions how to acquire this product and who to contact, what volumes are we talking about now, and how should they do, Philipp?
Well, the easy answer is contact me. Then you're at the right place. Of course, we will try to distribute our calcium phosphate together with partner companies and everything at different places. Give me a call and I tell you all about that. Concerning the volumes, of course, like with any new technology, we start at a average size. So first 1-2 years until 28, we will produce 15,000 tons in total per year. And as I mentioned, this until 2032 or maybe even 2031 will quadruple. So latest by 2032, we're going to have 60,000 tons of RevoCaP on the market available. And that's not the end. We're going to grow more.
Perfect, thank you. Now we'll move into the questions and answers session. You as a viewer will now put in your questions, comments, and all the speakers will be available for you to respond to them.
So welcome back, and now we are live. The recording you have seen was recorded in September, but any questions that you might have, we have all the speakers except Therese. She also mentioned she will not be there, so we have a replacer. But before that, before I introduce Asko Kinnunen, I will give some reflections, and I need to do one adjustment. Now we have the pin on the right side, and sorry for that during my recording. since last time, I have been able to also to visit Austria, and that was a 2-day session together with the different Nordic embassies. And the theme from my side was, of course, the pre-launch of our RevoCaP product in Austria, especially to understand what are the potential in Austria and how is the soil conditions in Austria. And it was confirmed that especially the organic farmers have a big problem because now the phosphorus are depleting. So what was also said in the recording already that you have seen just was also confirmed from the field. So there is really an interesting need for the product. But now let's introduce you to our new speaker. That's Asko Kinnunen from EasyMining, and he is responsible for the product development of the organic farming product. But first, before we invite the others to come on stage, Asko, who are you, and could you please give us your short introduction?
Yes, good morning all. As said, my name is Asko Kinnunen, and I recently joined the EasyMining team as a product manager. And as you already mentioned, my main responsibility is the development of the RevoCaP for farming application, and the priority is for organic fertilizer use. And about my background, I come from the fertilizer industry. And for the past years, I have been working on the development of recycled fertilizers. And the focus has been developing the product and the solutions that are suitable for organic farming.
It seems you're perfectly fitted for this work with us at EasyMining. What I would like to do to understand is also, of course, your priorities. What are you doing now for the moment?
Yes, as already mentioned before, that we are currently at the very stage. The plant in Skopau is under construction, and we are not too far away from the point when the first RevoCaP product will be on the market. And now the prior element is the trial program to support launching and sales of the RevoCaP product. And quite well how RevoCaP performs. We have done quite a lot lab and greenhouse trials, but now we are moving to field trials and what we are now planning and setting up. And the focus is now the local trials in the potential market areas and with the relevant crops, so that we have very valuable data of the performance of the RevoCaP when we are launching the product together with our partners. And of course, we have now discussion ongoing together with the colleagues, with interested and potential collaboration partners, like distributors or fertilizer companies. And also, as Therese mentioned during her presentation, RevoCaP product will be available both powder and granulated form. And when the product is used as a raw material to compound fertilizers, powder for sure is the best solution. And we have now already tested different techniques to granulate the RevoCaP, and we are now continuing with the pelletizing techniques to find the best quality product for direct application use. And these are the priorities for me at the moment.
There's a lot of priorities. Thank you so much, Asko. We have a first question before I can answer that one by myself, I think. Keith Langevald, you asked about hydrochloric acid and supply. It's not really about the RevoCaP product as such, but we are building now 2 phosphorus factories. So, of course, supply of hydrochloric acid is secured. And we have a line of another 10 in pipeline, the equal size of the first plant in Skopau. So, of course, this is secured and will not be an issue going forward. By that, I like to now come into more of the questions. And first, I think Philipp, if you can answer the topic about toxification and how remove that and how can we secure that it's not in the product. That was something that we also explained, but please, can you repeat that? How is the process working?
Yes, very simplified. We also received in this question, by the way, thank you for all your questions. We had this question, okay, sewage sludge has a lot of contaminants. That is true, especially in densely populated areas where you have industry and so on. And this is exactly the reason why we do what we do. Sewage sludge has the phosphorus, but it has the contaminants. So how do we separate that? It's very simple in that sense. For example, in Germany, most of the sewage sludge gets incinerated at minimum 850 degrees, which breaks down all the PFAS and organic pollutants, and you end up with a nice sewage sludge ash. And this is our raw material that we process. And what we do there, we dissolve the ash, we separate all the constituents, which means also we separate out the heavy metals completely and selectively take out the phosphorus at the end. So this way, the end product is very clean and also the heavy metals are out of it. That's exactly the main reason we do what we do.
I think there's a direct question also that I would like that we can pinpoint directly to you, and that is, of course, when we are incinerating sewage sludge, do we mix that with other things? And what's happening when you're mixing it? Will it work to mix with tree or other things?
Well, since we don't have much time, short answer, no. The sewage sludge ash that we use as the raw material to recover phosphorus is burned in so-called mono sewage sludge incineration plants, meaning it's incinerators that only burn sewage sludge. There's also legal implications that it needs to be done like that. So the simple answer is no, it's only from sewage sludge and nothing else.
I understand the reason is also because the more you dilute it, the lower will the phosphorus content be. So mono incineration will, of course, be more valuable for the wastewater treatment plants. I know there's a question that also popped up, and that is, of course, what will we do with when we were saying that the wastewater treatment plants, this will be an alternative route to what they do today. And of course, the ash-to-phos process are dependent on high volumes. So the most densely populated areas in Europe are in focus, like Germany, like France, like maybe Italy going forward. And that's where the ash-to-phos factories in Europe mainly will be. Otherwise, I think we will have ash-to-phos factories in the future in New York, Tokyo, or other places in the world where you have a huge amount of people. Good. I think what we can do now, and we have a very technical question about CMC 13. Thank you for that one. We will come back to that in a direct email response to you because it's a very technical question. But I'd like to invite now also Jenny and Sarah to also reflect on what has been said by the others, and also what if you have some response to some of the questions. So I start with Jenny.
I think it was a very good, very, very interesting webinar. It was great to hear from Philipp about the market's potential and also just the process. It was a great question asked, and I think Philipp answered it very well. I think it's very clear when you listen to all these presentations how relevant RevoCaP is and the technologies that are used to create the product. Like it's incredibly valuable to find a solution, or it's so necessary to find a solution to this phosphorus problem we have in traditional farming. And I mean, Sarah discussed it also in her presentation. And I think RevoCaP and EasyMining's technology is a great solution to this, and also creates a very useful product. So I think it was very, very good to hear from everybody, and thank you for the questions. If you have any further questions, you can always email Sarah, and she'll pass them on to me if you have anything for me as well. But yeah, great job, and thank you, everybody.
And then we go to Sarah in Germany. What is your reflections based on what you have seen and the questions that has popped in here?
Yes, hello everyone. It was very interesting to listen to all the inputs, and I think it's very important, as Jenny also mentioned, that a lot of testing has been done, which is very relevant because as we have seen that the efficiency of a certain fertilizer, in this case it's RevoCaP, so it's important to test it under different conditions and different crops, because we know that the efficiency differs a lot, and also to like this a bit find out where is the best place to apply it in the end, and to have also like some recommendations for the farmers. And yeah, it's as mentioned in my presentation as well. So recycling phosphorus is super important, and also like this the project we are working currently on, the Scale It project, is exactly such such products will be then also evaluated, and we will promote that this will be then also more publicly accepted, with doing workshop with farmers and with providing more information. So I was very happy to have here that presentation, and also to listen like how far it is, what has been done in all the different areas for the development. Yes, and thank you very much.
Thank you, Thora. Asko, I mean, your reflections, you started with presenting yourself and what you do for the moment, but what do you see is when it comes to the potential? You and I also visited Norway this week, and we also saw fish larch as a potential source. But please give me your reflections.
Yes, I can say that we have very unique product, because as it's what we have discussed already earlier, it's extremely pure phosphorus product, and also very concentrated, and as it is also suitable for organic farming. I think that is, at least from my side, the highlights.
Good. Philipp, of course, I like to end with a question to you, and that, of course, I understand the product will be available from something 2027, but what about the price and the volumes? What can you forecast? Please give us some hints.
Yes, as indicated earlier during my presentation, the capacity of this first plant that we get into operation in 2027 is 15,000 tons a year. So probably in 2027, during the startup phase, a little not full capacity yet in this year. But that's the volumes. We have the rollout plant as set to reach like about 60,000 tons per year at different production sites in 2032. And so that's about the volumes. And like I said, it will be distributed with partners in Europe. And of course, what's important is the price level. Of course, for the farmer and the end user, the price level is important. And we're very realistic about that. We want to compete with classic fertilizers that are on the market. That means the price level will be in the range of triple superphosphate. A bit of an adjustment factor for the P content correction, but that is the price level you can expect. And TSP currently has a price of 600 euros. So this is something, the ballpark, to say so, where the product will be located.
Thank you so much, Philipp. Thank you so much, Asko. Thank you so much, Sarah, and also thank you so much, Jenny. And of course, Therese, that now are home and will come back after some good time with her new baby coming. So anyhow, thank you so much for listening to this one and seeing it. And if you're interested to find out more, we are available at your disposal. And so you understand, this is a really high quality end product. There's a fast process focusing on producing end products that are even better than virgin produced resources. So therefore, it's a very unique solution that also will have very high quality and high prices in the end output. So by that, thank you all, and let's connect afterwards and respond to more of your questions offline. Sorry.